Five, four. Hello, everybody. Today we are starting ML track with Suman's talk, Multimodal RAG with Bedrock. Suman is principal developer advocate at AWS, and he has spoke like 250 at global events. And floor is yours, Suman.
Sure. Thank you so much. Hello, everyone. Thanks for joining in. Um, so today we are going to talk about multimodal RAG with Bedrock, and what we are going to do in next 30, 40 minutes or so. We will try to dive deep into multimodal RAG and what it is, and we'll try to understand how you can leverage this to solve some seriously critical problems. Okay? So let me just share my screen. Give me 1 minute, and then we will start from there. All right, so let me share my screen. Okay, I hope you are able to see my screen. Um, and in case you have any questions, feel free to put that in the chat, or you can ping me at later point in time over LinkedIn or email, whatever is comfortable with you. But my idea is to make sure that you understand a little bit about RAG and how this can be used to solve a certain complex problem. Okay, so I just have one slide because I wanted to spend more time and explain a few of the things as we go along. Okay, so let's see. Uh, so what is RAG at its core? If you think about it, if you're not coming from this background, uh, we have large language model these days, and we have been using it for our day-to-day work. Even if you're not from the data science or machine learning background, you might have been using ChatGPT or any chat tool like that, powered by one of the foundational model or large language model. Now, this works fine, but in situations when you have to use these intelligent models along with your data, there are multiple options where you just cannot survive with a regular prompt. So you can either fine tune a large language model, which is again it's not so complex process, but it's relatively complex, or you can use retrieval, or basically what we call it as RAG, retrieval augmented generation, where what we do essentially is when we ask a question to a large language model, we don't get the response, right? But with RAG, what we essentially do is we store our data in a vector database. And the reason that we store it in a vector database, not in just regular database, is because uh, that is how we can search for our information, which can be retrieved and later on can be processed by the large language model, right? So that's the whole idea, because large language model, they don't understand beyond vectors or numbers. So that is the reason that we are storing it into a vector database. Otherwise, we could have just used any relational database and just throw the relational database output. So that is how RAG works. So imagine that the way that the intuition that you should build is something like that. So let's say you came to me, and I am in a library. I am a librarian, and you wanted to understand what is TCP/IP. So let's say I don't know what is TCP/IP, but I know that there are some books in this library, and I can go and I can pick few books. Uh, it is very natural that TCP/IP would be there in networking, computer networking books, and computer networking books are, let's say, stored in that corner of this library. So I will just go there, pick up few of those books, and maybe I will just say that, okay, take these 5 books, read chapter number 1 from book number 1, chapter number 10 from book number 2, and so on. And I tell you that, okay, go and find your answer. So this is what essentially RAG does. So it is not giving you the exact answer, but it is giving you some context. In this example, it's in this analogy, the book chapters of different books is the context or the relevant information for your question. And then what you do is you go back home, you just read through those chapters and try to find out the answer yourself. And similarly in RAG, what you do is you had your original question, what is TCP, and now you have those a chunk of information, and then you send these two, your prompt and the chunk, to the large language model, and then the large language model is able to give you the right answer. Right? So that is kind of RAG 101. Now, I'm very sure that you all have been reading a lot of PDFs or documents and all of this since we were in school or college. Now, if you think and look back, how many of those books or PDFs or data in general contains only text? Very few, right? So you pick up any book, that book would contain images, tables, texts, and so on and so forth. And this is where multimodality comes, where we think about the data not only containing text but also containing different forms of information in the form of images, tables, and so on. Now the idea here in multimodal RAG is how we can extract these kind of information, right? So when where your data is coming from different format, the few of the information might be in the form of table, few information you might be in the form of images, and so on. Now how you will convert that into embeddings and then do a semantic search, right? So that's the whole premise. So let's see how we are going to do this. So imagine that you have this document, and this document contains images, tables, and text, right? So these are the things that we are considering for this example. Now the first idea that we have to think about is how we can extract images, tables, and text from this document. So there are different frameworks and packages available, and we are going to use one of them in the demo today. But a few of the tools are like Unstructure, then PyMU, and so on. But whichever package you use, that doesn't matter. You can test, you can see that which one works the best, and then you can use that. But the idea now here, and this is where the most important thing comes in when it comes to multimodal RAG. So what we will do from this stage now, I started with a document, and now I have extracted images, tables, and text from that PDF or from that document. Now the first option that I have is I simply use a multimodal embedding model which can create vectors given an image, table, or text, whatever it is, right? You just give that model, and that model should be multimodal in the sense the model can take text as well as images, right? If you have that kind of model, you just use that model and convert that into vectors, and all those vectors will be in the same space, right? So everything would be in the same a linear space, or rather vector space, and then we store it in the vector database. So what do we mean by saying same space? The way that you can think of it as uh, if you have a text about iPhone, right? So let's say you can say that, okay, iPhone 16 got released in so and so a date in 2024. Let's say that's a plain text. Now you do the embedding for this, and then you do an embedding of an image of iPhone 16. When you compare those two embeddings, it is very likely that these two embeddings will be very close to each other. Right? So that's why we say that images, text, tables, whatever it is, if we are using any multimodal embedding model, we expect that model to generate the embedding in such a way that image, text, tables, whatever it is, they will be close to each other if they are semantically similar. Okay, so that's a simple approach. And once we have this information in our vector database, what we can simply do is we can use just that information. We can just search for a query, we can search for anything that we would like to, and we will extract that information from our vector database, create our prompt, and send it to the final multimodal LLM, right? So this model should also be able to take images and the raw text. So you can ask any question about, let's say, when when this image was taken of Mona Lisa, whatever it is, right? So you can ask the question. It should be able to extract the information from your vector database and send the image and the text. And this text is your question, right? And you expect this multimodal model to give you the answer. This is option one, and this is what we are going to discuss today in the demo. But there are other ways that you can solve the same problem. So if you look back, the problem is very simple. You have a document which contains different types of data, and all we have to do is we have to store it in a vector database in such a way that when we ask any question about that document, whether that question's answer is there in an image or within a table or within a plain text, it should be able to get the answer, right? So this is the problem statement that we have started off with. So there is another approach that we can do. What we can do is uh, we will take the image, we will take the table, we will take the text, and we will create a summary of that. So this model that you see here, this model, what this model would do is this model will just create a summary of image image data, table data, or text data, whatever it is, right? It will just create the summary, and then we will create the embedding of that summary. Because once you have a summary, then it's all plain English, right? So if you give me, and let's say, image of an iPhone, and if you give that image to a model which can generate summary given an image, it will just create a summary, right? So like something like, this is an iPhone 16, yeah? And it has 256 GB memory. So now that plain text can be further used for embedding by any model which is just a text embedding model, right? So now what we will do is we are going to take only the summary and store them in a vector database, right? So the important and key thing is that we are just storing the summary. And the reason that we are storing it in the summary is we feel that summary is easier to search. Okay. And what is most important in this pipeline is that when we finally go and ask the question to the LLM, we will just send the summary and the question. So there is no image. If you look at this model doesn't have any image, right? So it will not take any image, and that's why we say that this is LLM, right? This is not a multimodal LLM. So this is just an LLM. So here you ask a question and you get the you search about that question in your vector database, and in your vector database you have just stored the summary. So you will get some chunk which is a summary of a text or a table or an image. So you take that summary and you get the answer, right? So this is how you will construct your prompt, right? With summary and raw question or your real question. In the option one, we saw that it is taking an image along with the question, but here we are giving the summary and the question. Different, and this is one of the technique that works in many for many organization and for many different use cases. And that is something like this, that goes something like this. So here also we are going to use multimodal LLM, and here we are going to use image and our question. Okay, but the important thing is how we will get this image, because we are not saving the image anywhere in the vector database, we are saving the summary. So what we are going to do in this option is, when we create the summary of the image, we will store a hash map. You can think of it as a dictionary, which will just say that image ID 1, and this is its summary. Image ID 2, this is its summary. So you always have that hash map or a dictionary stored somewhere. You can store it in a separate database or wherever it is. It can be in memory as well. But if you have a large database or data source, let's say you have hundreds and thousands of PDF, you may like to store it in a much more efficient memory based database. So in that hash map, what we are going to store is the summary and the ID of the image, so that you know summary X belongs to image number 1, summary Y belongs to image number 2, so on and so forth. Okay. So now what you will do is when you ask a question, it will first will be searched in this vector store, and this vector store will give you some context, right, or chunks. And that context might be an image summary or a raw table summary or a raw text summary. If it is an image summary, you will get the summary, and then you will go back to that hash table or that dictionary and try to find out this summary belongs to which image. And then you take that image and you pass that image along with your question. Okay, so this is a very smart technique where you have decoupled what you are embedding with respect to what you are actually sending to the model, right? So here we are embedding the summary, but here we are sending the image, right? So this is how we can decouple. And how we are able to decouple this? Because we are storing the mapping between the summary and the image in a different data structure. For example, a dictionary. So this is also another option. Now there are different techniques for implementing option 1, option 2, option 3 here, and there could be different more flavors to that. But this is kind of covers majority of multimodal RAG pipeline. So today what we are going to talk about is the option number 1, right? So let me just go to my notebook. So if you see here, okay, I think there is some question from Jonathan. So let me just try to answer this. Are multimodal embedding currently proprietary, or do we have some open source options available? Yeah, I think there are some open source models, embedding models are available. You can check in on the internet. I have worked with Cohere and Titan models, and we are going to use Titan. But there are certainly a lot of open or publicly available. Whether it's open source or not, I'm not very sure, because there is a different definition that are used. But there are a lot of publicly available models available for you to use embedding. Okay, and my intent here is to give you an intuition how things work. I have used Bedrock for this, but if you want to try, you can use Bedrock with some other models, because Bedrock is not an LLM. Bedrock is a service through which you can access any model, and you may like to use different models as you wish. Okay, so I think there is one more question. For option 3, is the goal that we have in LLM1 is for search and LLM2 for a specific use case? Okay. So the first LLM, if you, Jonathan, if you see this where my mouse pointer is, the first LLM is is the model which will generate the embedding. Okay, that is the only task of the first model. And for any RAG application, the first thing that you have to do is convert your data into embeddings. That's all. Now, how you do that, that is a different thing. But once you have the embeddings, then you store your data in the vector database and forget about it. Right? And the second LLM which we have, so this is the LLM which we will use for generating the final response. And so this is the final LLM which will generate the response for your customer or for your application. Okay. And Nally, I think you have one question. What embedding model do we use to summary? Yeah, that's a good question. So there are different embedding models that are available, which can just generate image to summary. So you might have used a lot of models which can take just image and generate a text, right? And text would be a summary of that image. And then what you do is you use another model, right? There are two models that you will use typically in that case. You use that text as an input to that embedding model, and that embedding model would be any embedding model, text-based embedding model, which takes a text and generates an embedding. So the way that you can think of this is here, summary and text embedding. You can think of this as a two models, one after another, right? Or the way that you should think is you have to first find out the summary, and for that you need to use any model. It could be a general machine learning model as well. It doesn't have to be large language model, LLM, because there are a lot of vision based models available, which just takes an image and generates a summary, right? It's a very old problem, when given an image, you generate the summary. You take that summary, and then finally you have to use a embedding model. Okay, so I hope Jonathan and Nali get some answer. And for image and table, we will just go through the code, and I think it would be you will be able to get that. Okay, so let me continue with the demo now. So we are going to go with option number one. We are going to the first task would be take the document, break it into images, tables, and text, and use some model which will create the embedding, store it in a vector database, and then we will try to ask question. Okay. So let me just go over this. I think there is one more question. So let me just go through this and then I'll come back to that question. Okay. All right. So first we are going to import a few libraries which are important. So we are going to use uh, PyMu PDF to read the PDF, specifically to get the images from the PDF. We are going to use Tabula for extracting tables from the images, and you can use unstructured as well. So it doesn't matter what tool you use. So these are the packages that this is the layer where we are talking about, right? Our intent is to get images, tables, and text. How we are going to do it's completely up to us, right? So that is kind of a prerequisite. So let's see how we are going to do this. Okay. So the first is data loading. So your data could be lying anywhere. So in this case, it is stored in my local laptop, right? And if it is in some cloud-based storage like S3 or any object-based storage, you can just give the path here. And then you can just see the data. So this is just the research paper. Attention is all you need. This is the paper which changed the whole dynamics of machine learning. So this is an 11-page document. So this is the data set that we are considering. And if you see, if I just scroll, there are some images here, and there are some tables as well here, right? So we have a mix of everything in this. So this is a good data set, right? So if you see this, we have tables here and so on and so forth. Now let's see how we can extract the tables, images, and the raw text, right? So what we are going to do is we are going to have some uh, directories created, if not already available, which will store the images, text, and tables. Right? These are the three things which are important. And then what optionally we are going to do is we are going to save each and every page, the full page, as an image as well. Right? So this is something that you may like to use when you do the last at the last stage of retrieval, right? So you may want to just find out not only the image but the whole text in that page where the image is stored, and then you send everything to the final LLM, and final LLM will find out the answer for you, right? So this is kind of it's like telling somebody that okay, go read this page. Go to this page number 5 and read the first paragraph. But when you are giving that person the literature, you are just giving the whole page, right? But you are also telling, just read the first paragraph in that page. Right? So you are giving a little bit more information so that he or she can get better context, right? So that is the reason. Otherwise, these are the three things that we are interested in. So let's see how we are going to do this. So we are just using some chunk size. So this is how the text data will be chopped. The text size would be very big, right? So we want to store it in small chunks. So we are going to use character based chunking. So this is something that we are going to use from LangChain, right? So I have imported this recursive character text splitter. There are different splitters available. If you go up, you will see that there are a lot of different text splitters available. We are going to use recursive character text splitter. And what it does is it will just split the text every after 700 characters. And when the next chunk will start, it will have an overlap of 200 characters, right? So the let's say first chunk ends here, the second chunk will not start from here. There will be some overlap, right? So that is the whole idea. So now let's see how we are going to process the PDF. Okay. So first, we are going to read the whole document, right? If you see this here, we have actually read the document here. We have read the document here. It's in doc variable. We know how many pages that it has. We are just getting the length of this doc, and then we are iterating over all the pages, right? We are iterating over all the pages, and this is the list that we have created, which we will populate gradually as we go along, and this will contain everything: text, image, and tables. Okay, so let's see how we are going to do this. First, let's extract the tables. Okay, so we are using Tabula. We are reading the PDF, and then we are trying to find out tables. So it will automatically find out the tables for us, and how many tables we get, it depends, right? So depending on the data. So we will just iterate over all the tables, and the way that we will store the table is just using some markdown, like simple annotation of the columns, because the reason is we will later on do the embedding of these tables, right? And for that we have to send the data in the form of text, but the text should be in such a format that it looks like a table, right? So that's why we are just doing some string manipulation here. And once we have this table text, that is the data of the table, we will just save it in the table directory, right? That's all. And now, once we have saved this table information into our directory, right, in a local storage. And what is this local storage? This is the local storage or the directories, right? Once we store that, we have to update the items dictionary, right, or the items list. So every time we find out a table, we will append an item, and that item will contain what is the page number, the type is table, what is the table text, and what is the table file name. Okay, and I will print and show you how this looks like so that you will get an idea of this. So we are able to add table information in this items list, right? So table is done. Now next is, let's say we want to store the plain text. So for plain text, we are going to use the text splitter from LangChain, right? Character based splitting, and we will just store all the chunks here. Now it will have a lot of chunks, right? So the chunks will be coming from different pages and so on and so forth. So we have to make sure that we append again on this items, right, in this items dictionary, and here we will have the type as text. If you see this, here we had the type as table, here we will have type as text. And lastly, the images. So for images, we are going to use PyMU PDF. We are going to read that image, and then we will just save those images in our image directories. And next, we have to store the image as well. So the image that we are going to store is using base 64 base encoding, right? Because that is the embedding, sorry, that is the string format or image format any model accepts, right? So we are going to just encode it using base 64 encoding, and then we will update our items list again, but this time the type will be image, right? So at this point, we extracted images and stored it. We extracted text and stored it, and we extracted we extracted tables and stored it, right? So we actually could extract everything, and we have everything in this items list, right? And so let's see how this looks like, right? So this will take some time to process, but then once it is done, you can see how the texts are stored. If you see here, see this page number 0, type is text, and this is the raw text and the location of this, right? So it's clearly showing where it is storing and how is that. So if I just switch my tab, and if I go to data folder, and let's say process text, you see this, This is the PDF name and text number 0, page number 0, and chunk number 0. And if you click here, you will see that attention is all you need and all the author name and everything, right? And the abstract. So this is very much like the actual PDF itself, right? So if you see this PDF, okay, here the PDF will not open. Let me just show you here. If I just scroll up, yeah, if you go to page number 1, see this attention, all you need, then the author name and the abstract, right? So it looks like it has created the first chunk only till here, right? So you get the idea. So similarly, if you now see how the tables looks like, you can see this. See this page number 10, type is table, and the items or the columns are stored in like this. So there is a pipe in the middle, right? So you see this, there is a pipe in the middle, and this is what we have done intentionally, right? So if you want to see this again, here you can see this processed tables, and let's see this table 80, and see the table here. There is a lot of NaN. That means the table must have empty character or nothing was there in that table, and we can actually validate that. So this is, see this, this is in page number 8, right? So let's see what is there in page number 8, so that we can get a better idea, right? So let's go to our PDF and let's go to page number 8. Okay, and I think it should be not page number 8 but page number 9, because it's indexed from 0. And see this, there are a lot of places which are empty, right? So that is the reason that it was NaN, right? So I hope you got some intuition about how we are processing the data and why we are processing the data in a certain way, right? And similarly, for images, we again storing what is the location of the this image. This is in page number 2, type is image, and this is the image, right? So again, let's go back and see this image. So this is data, and this should be an under processed image, and we can see, let's say, the first image, and we can see that there is the transformer architecture, right? So we have everything as we wanted and the way that we wanted, right? So we have everything, and this whole big messy chunk is basically the base 64 encoded information of the same image, right? So at this point, if you see all the items in this items list contains the page, the type of the page, and the text. All we have to do now is to generate the embeddings for all of this, right? And we are going to use a multimodal embedding model for this. And for this, we are going to use Titan based embedding. Okay, so we have an Titan based Amazon Titan embedding model, which can take images as well as text, and it will create an embedding for you. So let's see how it will create an embedding. Okay, so here we have to define what is the vector size of your embedding. So in this case, we have set it to 384. So the way that you can think of embedding, dimension is something like that. Uh, let's say if I tell you that my name is Suman and I work for Amazon. So I have just given you two information about me. Now, no matter what people ask about me, you can just answer based on these two contexts, right? Or these two features, right? In this case, right? Where I work and what is my name. So you can think of this as I have given you my information in a two-dimensional vector. But let's say if I tell you my name is Suman, I work for Amazon, I'm based out of Boston, I have one kid, I am originally from India, and so on and so forth. So in that case, you have a lot of information about me, right? So let's say if I throw you 10 different information or 10 different features about me, intuitively you can think of it as I am giving you the information in a vector form with 10 features or 10 dimensions. So in this case, when I say the vector contains 384 as a vector dimension, that means whichever data that you will give to that model, the model will convert that data into a vector which will contain 384 numbers. And every number will define some feature. What feature, and we are not interested in that, and we cannot find that as well because it's a black box, right? So, but this is how the embedding will impact the dimension of the embedding will impact on the search, because the more information you have, the better you know about that particular thing, right? So that's why people will say that generally when you have a larger dimension of your embedding, you will get a better search result, right? Because you are storing more information. And the way that we are generating the embedding is like this. We are going through all the items, and we know that item could be text or table or images, right? So if it is text or tables, we are just sending the prompt, the text part of that, and we are just giving the vector dimension. And if the item is an image, then we are sending the image part of that dictionary, right? Item images, image. So just because we have two different things, we have created a wrapper function called generate multimodal embedding, and which is this function, and it just takes either prompt or image. So image is prompt is nothing but the actual text. I will change this key to text. I think that is more meaningful, just to avoid some confusion. But this is the text part, which will contain either plain text or table, and image is image, right? And this is the vector dimension. And why we need to have these two options? Because the way that this model, right, Amazon model works is it expects images as well as text. And there is a difference in the request API. If it is text, you have to give as input text, and if it is image, you have to give as input image, right? So that is the whole reason we created this wrapper function. Otherwise we would have called the uh, Titan embedding models directly from here, right? And this is the advantage of using Bedrock. The way that you can use this LLM is just by creating and Boto 3 client object. Boto 3 is the SDK to access any AWS resource, and you can say that Bedrock runtime, and then the model ID is this, right? So let's say you want to use a Cohere model, right, or some other model. You just replace this with a different model ID. That's all, right? So you don't have to make any other changes. All right. So once we have this, we have all our embeddings, right? And if you see this, we have 84, 85 rows and this many columns, right? And if you think about it, if you just now see the length of items, it should be 85 as well, right? So we had 85 items. And if you remember, let's see the items number 0, right? If you see this, it has page number 0, type is text, and this is the actual text, and this is the path of the text. And you see this now, we have now added embedding, right? And this embedding got generated by this function, and later on we added this like this. Okay, so this is the only thing that we did. Okay, so all till this much we have processed beforehand itself. Now we have just added embedding to all those different types of data. So now that we have our embeddings, we can store it in a vector database. So for this, we are using FAS, or whatever, howsoever you call it. But this is an publicly available framework, or a module. You can just do pip install, and you can store it in memory or within your system. But in ideal case, you will use some vector database, right? On cloud, like on AWS, we have OpenSearch, Aurora, and so on. But you can use any vector database like Pinecone and so on. But here we are just adding all the embeddings in this vector database, right? So once we have this vector database, that's all, right? So we are done. Now we can just simply search. So let me just, before I test this, let me just scroll up, and let's revisit where we are. We divided the data into image, text, and tables. We use the Titan model to extract, to create the embedding of all different types of data, and we stored it into this vector database, which is, for this we use FICE, but you can use anything. And now we are in this section, right? The last and final section, where when we ask any question, we have to use the same embedding model to generate the embedding. And that embedding, we will be searching in this vector database. Whatever context we get, we will add that context along with our question and send it to the final LLM. Okay, so let's now go back and see that how we are going to do this. Okay, so this is pretty simple and fairly easy. So let's come to the last section. Okay, so okay, before that, I think I should discuss this. How we are going to ask this question. So the question will contain the prompt, which is our question, and the matched item. So matched item are the items which are similar from the vector database, right? We have to do a semantic search, right? That's the whole idea of storing our embeddings in the vector database. And once we will see how we get this matched items. But once we have these two things, what we do is we simply create a prompt which contains our text and the prompt. So the prompt is simply the prompt, that is the actual question, and the text is something that we are creating. And how we are creating? We are creating it using this matched item, right? Because the matched item can be text or image, right? So if it is text, we are just adding that, we are just taking the page number and the actual text. And if it is image, we are just taking the base 64 based encoding of the image, right? So this is where you can play around it, what type of data that you want from those matched context. Okay, and then you just create your text this text context, and you just add it here. That's all. Okay, and finally, once you have your final prompt, you can send your final prompt and the image context. You don't have to make any changes in the image context. It should be as it is, right? If there are 4 or 5 images you figured out is semantically similar to the question, you will just have the base 64 based encoding of the image and send it, right? So that's all. So now let's see how we are going to test this. So we ask a query, right? So let's say, how is the scale dot product attention is calculated, right? So first we have to generate the embedding for this, right? Because why we need to generate? Because we are going to search it in our vector database, right? And to talk to the vector database, we have to get our embeddings, right, in the form of vectors. So we use the same embedding model to generate the embedding for this query. And then what this function what this will generate is the embedding of the question. And then we will just do an index dot search. So this is the vector database index. We are doing a search on this query, and we are saying that give me the top 5 results. Okay, just top 5 a similar context. And these are the 5 contexts that it generated, right? So these are nothing but the index of those context. So what that means is we have this everything stored in items, right? So this is like item number 21, similarly item number 19, 20, and 23, like all this are my matched context, right? So let's see this. So this is one of the matched context that we have, right? So now since this matched context contains everything, right? The page number, text, actual text, and the embedding, we don't need everything, right? And that's why we will just retrieve what we need, right? We have created a function for this, right? Generate a RAG response, and we send the query and the matched item, right? You remember this is the function that we just looked into, where we send the query and the matched item. If you remember this one, prompt and the matched item, right? So once we do that, we can simply get the answer, and we can just print the response, right? So this is how you can easily get that information. So what you're essentially doing is quite a complex task. You are now building an application, or now you have built an application which can answer your question where the data can be of different formats, right? And you can, in fact, ask questions regarding something which is stored in that document in the form of a table. Right? So this question, I have tested this, and I will be sharing this notebook. You can play around, and you will see that these questions are answered from a table. Right? See this, according to table number two, blah blah blah. This is the answer. Right? So these are few of the other questions that I have. You can simply, try these questions, and in the similar format, you create the embedding, find the similar results or the closest match, and then send that matched result along with your query and get the response, right? That's always the case. And yeah, so that's how you can build an application using multimodality or multimodal RAG, uh, where you have data of different types. Okay, so before I stop, I think there are we still have a couple of minutes. So if you want to learn more, this is the GitHub repo that I have. You can take a screenshot, or I can just let me just do this. Let me just paste this GitHub link. So this GitHub link, what I have talked about is, I will share you the full link for this. I just pasted in the chat. But in today's session, we just covered this notebook. Okay, multimodal RAG with Amazon Bedrock. But it has different notebooks where it starts with multimodality, how you will use that, then retrieval, and then there are some applications as well. So you can play around, and you can pick whichever you feel like. There is also a folder called LangChain. If you are new to LangChain, this will give you a good intuition about how LangChain works, what are the different techniques that we have to work with LangChain. Right? So this will give you some intuition about that. And there is one more GitHub which I will let me just share this. So this is something that uh, they're not very updated, to be very frank. But this is something that I've been working on for last 7-8 months, and it has a lot of different things, like how to get started with Bedrock, what is RAG, what is vector database, and there are small applications that you can get started with. There is one more thing which I wanted to share is, you can uh, uh, let me just search this 1 second. So there is one blog which I have written. I think it will be better if I search it here. Yeah. So there is some one blog that I have written some time back, and it's on vector database, which is little deep dive. So if you see this is part one, this is part two. So if you are new to embedding and what is embedding and all that, from the mathematical standpoint, this will give you some intuition about that. There are things that you can refer in case you need. I would strongly recommend you get started. Take any resource of your choice and try to try to print everything and see that what it is containing, right? So my intention of showing you all these structures, right, like this here, is to tell you and map it with the concepts that we have learned, right? Because in the image, if you remember, when we were talking about this, we are saying that raw text, images, and all this, but how that looks like in the vector database. So that is the whole intent, right? Okay, that you should understand from the implementation standpoint how things work. There are a few things which I have not shown here, but I would strongly recommend when you go through this notebook, you create a copy of this and then print each and every statement so that you understand what is happening and why it is happening, right? So that will give you a better understanding. So let me see if we have any other question. I think, okay, so there is a question. How do we guarantee the full table are processed when we are creating embedding? Yeah, Jonathan, that's a good question. So this is where you have to keep testing and see that which model works for you, because at the end of the day we are not creating or training a model, we are just using it as it is. So that's why I have shown you all these tables, right? So and what I will do, or I have done for this when I was working on this demo, is I went to the PDF page and I tried to see that whether this is right or wrong, right? And this is how you can use different frameworks like unstructured, or in fact you can create your own regex as well, but it's completely up to us. Okay, so let me see what is the next question. um, Divya Raj, I think you asked about the notebook. We shared that. It should be fine. Jonathan is asking, um, are multimodal embedding created using the same mathematical model, or they are distinct model? Okay, that's a good question. I don't think we have time, but I'll give you a basic intuition of this. Okay, your question is more on how we train a multimodal model, right? Uh, there are different techniques. You can read about one of the technique that is predominantly used, called uh, clip. Okay, so how that works is, we first generate the we use different embedding models which can process only image, only text, and so on, and we get their embeddings. So those embeddings are independent of different types of data. Now, what we do is, we take those embeddings and then we train the actual model. And the way that we train is, we create our training data in such a way that we take, let's say, an image of a cat and a description of a cat, and then we expect these two embeddings are closer to each other, and that is how the loss function is created. We create a loss function in such a way that embedding of an cat and embedding of the description of cat are similar or close. And let's say, image of a cat and a description of a dog, or sorry, not dog, let's say, let's take something more orthogonal, a description of chair is very opposite. So that's how we train, and that model becomes a multimodal model, right? So there is, it's a quite a deep topic, but this is how internally we create or we train that model, right? There are different techniques, but this is one of them. Okay, there is a question from Cooper. Does anyone have experience with the construction of open search index document structure with extra metadata? Yes. So, see, open search is just another database, right? You can use any database. And if you think about it, the way that we have created our data contained everything, right? Our data contained page number, text, the type of data, the actual text, and the embedding along with the path. Now you take this data, which is in the form of a dictionary. Now you store it the way that you want, and you don't have to store everything. You can store whatever you want, and you can just ignore whatever you don't want, right? But which database works best for you, it depends on a lot of things, like what is the indexing algorithm that we have and all of this. And I'm not from the database standpoint, I mean expert, but you can go over a few of the databases and see that which one works the best. Okay. Okay. So there is one more question from Jonathan. Are multimodal embedding created using the same? Okay, we just answered this. I think one more question: is k-NN search is the primary method to searching the vector database? Yeah, it's basically that is what is predominantly used, because all you need is to find, let's say you have multiple vectors, right? So all you need is to find the closest three vectors or four vectors or five vectors, and vectors are already there in the space, right, in your vector database. All you do is you take your query, create your new vector, this is your query vector, and you just see which are the embeddings which are close to each other, right? And you just get the top five or top three. In our example, it was top five, but it could be top three as well. All right. So I don't think there is any other question. Okay, there is one more question.
Hello,
Yeah.
Suman. Actually, if we can wrap this session, that would be great.
Okay.
And yeah,
Yeah, sure. So I think I'll just take one more minute. There is just one last question.
okay.
Uh, could you just show us a query that returns that would return an original image and the summary of an image? Yeah. So we have not used this model, right? If you consider this second type, then you will get the summary. We have not implemented that, but just just clone this repo. I will implement the option 2 and option 3, and it should be within this directory, multimodal RAG. Okay. And Jonathan and others as well, if you have any questions on this, just ping me on LinkedIn, and I will share. If you don't see that, this is my LinkedIn. If you don't see that, I will be able to send you that. All right. Thank you so much for everyone for joining in. Really appreciate your time. And I wish you a great event and enjoy and happy learning.
Have some, Suman. That was great talk, and see you in the next session. So bye.
Thank you. Bye.